If you've heard about the 300-year-old human mummy unearthed in Alaska, then you know the secrets the ice hides. But what's buried beneath Antarctica's frozen ground is far more terrifying. Welcome to the most alien place on Earth, where temperatures drop lower than Mars, and beneath the ice lies a prehistoric nightmare. Imagine a land once filled with dense forests and colossal creatures. Towering theropod dinosaurs roamed the land, prehistoric crocodiles stalked their prey, and the Mosasaurus ruled the oceans, capable of devouring you in one bite. And then, there were the towering penguins, larger than humans, and amphibians the size of cars lurking in rivers. Antarctica wasn't always a frozen desert. Millions of years ago, it was a deadly, untamed paradise no human could ever survive. Today, it's a frozen tomb. But back then, it was pure nightmare fuel. Prehistoric Antarctica, a land that would make your blood run cold, not from ice, but from terror. A world where colossal penguins tower over humans, where monstrous marine reptiles rule the seas, and where even the plants could be your worst enemy. To understand the nightmarish wonders of prehistoric Antarctica, we must first turn back the clock, not just thousands, but hundreds of millions of years. Our story begins over 200 million years ago, when the world looked very different. All of Earth's landmasses were fused into a supercontinent we call Pangaea. Antarctica, as we know it, didn't exist yet. It was merely a piece of this giant puzzle, nestled between what would become Africa, South America, and Australia. As tectonic forces pulled Pangaea apart, Antarctica began its long journey southward. By about 160 million years ago, it had separated from Africa. Then, around 90 million years ago, it split from India. The final break came about 45 million years ago when Antarctica and Australia parted ways. At last, Antarctica stood alone, surrounded by the Southern Ocean, in the position we find it today. But this wasn't the frozen continent we know. For much of its history, Antarctica was a land of warmth and life. Forests covered its surface, rivers carved through its valleys, and a diverse array of creatures called it home. The turning point came around 34 million years ago. Global temperatures began to drop, and Antarctica started to freeze. This wasn't a quick process, it took millions of years for the ice sheets to form and expand. By 14 million years ago, the East Antarctic ice sheet had formed. The West Antarctic ice sheet followed suit about 10 million years ago. These massive ice sheets locked away so much water that global sea levels dropped by up to 80 meters. But it wasn't just the cold that transformed Antarctica. Its isolation played a crucial role. As the continent drifted south, a powerful current formed around it, the Antarctic Circumpolar Current. This current acted like a barrier, preventing warm waters from reaching Antarctica's shores. It sealed the continent's fate, locking it in a frozen embrace that persists to this day. And so, over millions of years, Antarctica transformed from a lush, life-filled land to the icy desert we know today. But the ghosts of its past remain, buried under the ice, waiting to be discovered. Today, scientists use ice cores, geological evidence, and fossil records to piece together Antarctica's incredible history. Each discovery provides a new window into a world long gone, a world of monsters and marvels that once ruled this frozen land. But to truly understand the horrors and wonders of prehistoric Antarctica, we must first confront one of the greatest catastrophes in Earth's history, an event so devastating, it nearly wiped the slate clean. Join us after the break as we explore the Great Dying. 252 million years ago, Antarctica was a very different place. Lush forests covered the land, bizarre creatures roamed freely, and life seemed to be thriving. But beneath this serene surface, catastrophe was brewing. We're about to witness the most devastating extinction event in Earth's history, the Great Dying. Also known as the Permian-Triassic extinction, this cataclysm would reshape life on our planet forever. It began with fire. Massive volcanic eruptions in what is now Siberia spewed lava and toxic gases into the atmosphere for thousands of years. The scale is almost unimaginable, enough lava to cover an area the size of Europe to a depth of 1 kilometer. These eruptions released enormous amounts of carbon dioxide and methane into the atmosphere, triggering a runaway greenhouse effect. Global temperatures soared by as much as 10 degrees Celsius. The oceans acidified and lost oxygen. On land, forests withered and died. The result was apocalyptic. Up to 95% of all marine species and 70% of terrestrial vertebrate species vanished. The Great Dying earned its name. It came closer to wiping out all life on Earth than any other event in our planet's history. Antarctica, despite its southern position, was not spared. The lush forests that had covered the continent were decimated. Many of the unique animals that had evolved there vanished forever. Dicynodonts, early relatives of mammals that had been common across Antarctica, were hit hard. The seas around the continent, once teeming with life, became eerily empty. It was as if someone had turned off the lights on an entire world. The speed of this extinction was unprecedented. While mass extinctions typically unfold over millions of years, the bulk of the Great Dying may have occurred in just 60,000 years, a blink of an eye in geological terms. But life, as they say, found a way. In the aftermath of this catastrophe, the survivors began to adapt and evolve, filling the ecological niches left vacant by the victims of the Great Dying. One of the greatest success stories was Lystrosaurus, a hardy, pig-sized animal that somehow survived the extinction and went on to dominate the early Triassic landscape. Fossils of Lystrosaurus have been found in Antarctica, proving that life endured even in this harsh environment. As the planet slowly recovered, Antarctica began to change. The forests that regrew were different from those that came before. New species of animals evolved, adapted to the post-apocalyptic world. This was a turning point for Antarctica. The Great Dying had reset the evolutionary clock, paving the way for the rise of the dinosaurs and the emergence of new, terrifying creatures that would come to dominate the continent. Today, geologists and paleontologists scour Antarctica for clues about this pivotal moment in Earth's history. Each fossil tells a story of survival against impossible odds, a reminder of life's resilience in the face of catastrophe. As we stand on the ice sheets of modern Antarctica, it's hard to imagine the fiery apocalypse that once engulfed this land. But beneath our feet, locked in rock and ice, lie the remnants of that ancient world, a world that was lost, and the new one that emerged from its ashes. But the story of prehistoric Antarctica was far from over. In fact, up next, we'll explore the incredible ecosystems that flourished in the wake of the Great Dying, as Antarctica entered its most spectacular era yet. Imagine standing in the heart of Antarctica. But instead of endless ice, you are surrounded by towering trees. The air is warm and humid. Strange calls echo through the forest. This isn't a dream, this was Antarctica for much of its prehistoric past. During the Cretaceous period, between 145 and 66 million years ago, Antarctica was a land of forests. But these weren't just any forests. These were polar forests, adapted to long periods of darkness and light. Conifers dominated these forests, their needle-like leaves efficient at capturing the low-angled sunlight of polar summers. Species like Araucaria, relatives of today's monkey puzzle trees, reached heights of over 100 feet. Beneath these giants, the forest floor was a carpet of ferns and cycads. These plants, which we now associate with tropical climates, thrived in the warm, humid conditions of prehistoric Antarctica. As time passed, flowering plants began to appear, adding new colors and shapes to the landscape. By the late Cretaceous, about 80 million years ago, deciduous trees had joined the mix, shedding their leaves to survive the dark polar winters. These forests were fed by a network of rivers and streams, their waters swollen with snowmelt during the warm summers. These waterways were lifelines, carrying nutrients and supporting a diverse array of life. Lakes dotted the landscape, some as large as inland seas. In their depths, strange fish swam, while along their shores, early mammals scurried in search of food. And then there were the swamps. These murky, humid environments were breeding grounds for insects and amphibians. They were also time capsules, preserving the remains of plants and animals in their oxygen-poor sediments, creating the fossils that tell us this incredible story today. The contrast between this prehistoric wonderland and today's Antarctica couldn't be more stark. Where once stood mighty forests, now we find barren rock and ice. The rivers and lakes are mostly frozen, hidden beneath massive ice sheets. Yet, life persists. In the few ice-free areas of Antarctica today, mosses and lichens cling to life, hinting at the continent's greener past. Two species of flowering plants, Antarctic hairgrass and Antarctic pearlwort, manage to survive in the harsh conditions. And beneath the ice, over 400 subglacial lakes have been discovered. These hidden waters, isolated for millions of years, may harbor unique life forms, evolutionary relics from a time when Antarctica was warm and green. This dramatic transformation didn't happen overnight. It was a gradual process, driven by shifting continents and changing climates. As Antarctica drifted south and global temperatures cooled, the lush forest slowly gave way to tundra, then to the icy desert we see today. But the story isn't over. As our planet warms due to climate change, Antarctica is changing once again. Glaciers are retreating, exposing land that hasn't seen sunlight in millions of years. And in these newly revealed soils, life is stirring. Meet Cryolophosaurus, the frozen crested lizard. At 21 feet long, this was the largest predator of its time in Antarctica, ruling the continent about 190 million years ago. But it's not just its size that's impressive. Look at that head crest, a thin, semicircular plate running from the eyes to the back of the skull. It's unlike anything we see in modern animals. Imagine this beast stalking through the polar forests, its crest perhaps used for mating displays or to intimidate rivals. With powerful jaws and sharp teeth, Cryolophosaurus was the apex predator of its ecosystem. Not all Antarctic dinosaurs were predators. Meet Antarctopelta, the Antarctic shield. This heavily armored plant eater lived about 74 million years ago, near the end of the age of dinosaurs. Antarctopelta was built like a tank. Its body was covered in bony plates and spikes, providing protection against the large predators of its time. At about 13 feet long, it was about the size of a small car. Picture this creature lumbering through the Antarctic undergrowth, feeding on low-growing plants. Its armor would have been a crucial defense in a world where danger lurked around every tree. But the terrors of prehistoric Antarctica weren't confined to the land. The surrounding seas were home to some of the most fearsome marine predators ever to exist. Chief among them was Mosasaurus. Up to 56 feet long, Mosasaurus was the T-Rex of the seas. This giant marine reptile had a skull nearly 6 feet long, packed with sharp, conical teeth perfect for seizing prey. Mosasaurus was the apex predator of Antarctic waters during the late Cretaceous, about 70 million years ago. It would have fed on anything it could catch: fish, squid, even other marine reptiles and sharks. While Mosasaurus ruled the surface waters, another bizarre creature patrolled the depths. Meet Elasmosaurus, a long-necked plesiosaur that seems to defy the laws of biology. Just look at that neck. At up to 23 feet long, it made up more than half the animal's total length. With 71 vertebrae, it's the longest neck relative to body size of any known animal, living or extinct. Elasmosaurus used its long neck like a snaking underwater arm, allowing it to sneak up on schools of fish from below. Its 4 powerful flippers propelled it through the water with grace and speed. Let's step further back in time, to about 250 million years ago. Meet Antarctoshackletonia, a small reptile that lived just after the Great Permian Extinction. Only about the size of an iguana, Antarctoshacks doesn't look impressive. But this little creature was a pioneer, one of the first archosaurs, the group that would eventually give rise to dinosaurs, pterosaurs, and crocodiles. Now, let's meet a different kind of pioneer. This is Antarctodon, a cynodont, not quite a mammal, but getting close. Antarctodon lived about 235 million years ago. Its teeth show something revolutionary: different types for different purposes, a key step towards mammalian evolution. Fast forward to about 4 million years ago. Antarctica is ice-covered, but its waters are still full of life. Meet Ostradelphus, an ancient Antarctic dolphin. This dolphin was adapted to the cold Antarctic waters, perhaps feeding on the abundant krill like today's Antarctic whales. It's a reminder that evolution never stops, even in the harshest environments. Our final creature takes us to the shore about 37 million years ago. Meet Paleodyptes klekowski, also known as the Colossus penguin. Standing at nearly 7 feet tall and weighing up to 250 pounds, this was the largest penguin to ever exist. Imagine these giants waddling across Antarctic beaches and diving into the frigid waters to hunt. From terror birds to colossal penguins, from sea monsters to tiny proto-mammals, prehistoric Antarctica was a land of extremes. Now it's time to meet one of its smallest, yet most fascinating inhabitants. Welcome to the world of Microbiotheria and its sole surviving member, the Monito del Monte. The Monito del Monte, or little monkey of the mountain, might look like a mouse, but don't be fooled. This tiny marsupial, weighing just 30 grams, is a living fossil, a window into Antarctica's distant past. Today, the Monito del Monte lives only in the temperate rainforests of Chile and Argentina. But its ancestors once called Antarctica home, when the continents were joined and the climate was warm. The story of Microbiotheria is a tale of survival against the odds. As Antarctica drifted south and froze, these tiny creatures migrated north, finding refuge in South America. But here's where it gets truly fascinating. The Monito del Monte's closest living relatives aren't in South America, they're in Australia. This tiny creature is more closely related to kangaroos and koalas than to any other South American mammal. This unexpected family tree tells us something crucial about the history of life on Earth. It's evidence of an ancient connection between South America, Antarctica, and Australia, a supercontinent called Gondwana. Imagine a world where you could walk from South America to Australia, passing through a lush, green Antarctica. This was the world of the Microbiotherians, a world that existed until about 30 million years ago. Fossils of ancient Microbiotherians have been found in Antarctica, dating back 40 million years. These tiny creatures witnessed the transformation of Antarctica from a green paradise to an icy wasteland. The Monito del Monte is more than just a cute, furry creature. It's a living link to a lost world, a tiny time traveler that carries the genetic legacy of prehistoric Antarctica in every cell of its body. To survive, the Monito del Monte has developed some remarkable adaptations. It can lower its body temperature and enter a hibernation-like state called torpor, allowing it to survive when food is scarce, a useful trick in the unpredictable climate of prehistoric Antarctica. The Monito del Monte reminds us that the story of life on Earth is one of constant change and adaptation. But it's not the only survivor of Antarctica's prehistoric past. Picture a world in ruins. The skies are dark with volcanic ash, the oceans are acidic, and 95% of all species have vanished. This was Earth after the Great Dying, the worst mass extinction in our planet's history. But life endured, and one creature emerged as the unlikely hero of this apocalyptic tale, meet Lystrosaurus. At first glance, Lystrosaurus doesn't look like much. About the size of a pig, with a turtle-like beak and tusks, it resembles a bizarre cross between a reptile and a mammal. And in a way, that's exactly what it was. Lystrosaurus was a descendant, part of a group called synapsids, the ancestors of all mammals. Its name means a shovel lizard, referring to its spade-shaped skull, perfect for digging up roots and tubers. But it wasn't Lystrosaurus' appearance that made it remarkable. It was its ability to survive. As the world burned and froze in the aftermath of the Great Dying, Lystrosaurus endured. Scientists believe several factors contributed to Lystrosaurus' survival. Its burrowing ability may have helped it escape extreme temperatures. Its tusks allowed it to feed on hardy vegetation that other herbivores couldn't eat. And it may have been able to enter a state of torpor, lowering its metabolism to survive when food was scarce. But perhaps the most astonishing thing about Lystrosaurus is how successful it was after the extinction. Fossils of Lystrosaurus have been found on every southern continent, Africa, India, Antarctica, and even China. The discovery of Lystrosaurus fossils in Antarctica was a crucial piece of evidence supporting the theory of continental drift. It showed that these landmasses, now separated by vast oceans, were once connected. Imagine Lystrosaurus trudging across the recovering landscapes of prehistoric Antarctica. The world is still harsh, but life is slowly returning. In this post-apocalyptic world, Lystrosaurus thrived. In fact, Lystrosaurus didn't just survive, it flourished. In the early Triassic period, immediately after the Great Dying, Lystrosaurus accounted for 90% of all vertebrate fossils in some areas. It evolved into several species, adapting to different environments across the supercontinent of Pangaea. Lystrosaurus itself went extinct about 250 million years ago, but its legacy lives on. As a member of the synapsid group, it was part of the lineage that would eventually give rise to all mammals, including us. Today, Lystrosaurus tells us a crucial story about life's resilience. In the face of global catastrophe, this unassuming creature not only survived, but thrived, helping to repopulate a devastated world. As we face our own era of rapid environmental change, the tale of Lystrosaurus offers both a warning and a glimmer of hope. It reminds us of the fragility of life, but also of its remarkable ability to endure and adapt. Lystrosaurus' journey from the ashes of the Great Dying to dominance across a recovering world is a testament to the power of evolution and the tenacity of life. But the story of prehistoric Antarctica is far from over. Stay tuned because coming up, we'll explore how shifting climates and drifting continents continue to shape this ever-changing land, leading to the icy realm we know today. The story of prehistoric Antarctica is one of constant change. From lush forests to icy wastes, from thriving ecosystems to barren expanses, this continent has seen it all. Let's explore the epic tale of Antarctica's climate shifts and the profound impact they've had on life itself. Our journey begins over 100 million years ago, during the Cretaceous period. Antarctica was warm and humid, covered in lush forests. But change was coming. Around 34 million years ago, Antarctica began to cool. This wasn't a gentle process, it was the start of a climatic roller coaster that would reshape the continent entirely. Over the next few million years, Antarctica experienced wild swings in temperature. Ice sheets would form, then partially melt, then form again. Each cycle reshaped the landscape and tested the limits of life's adaptability. As the climate changed, so did life on Antarctica. The lush forests gave way to tundra, then to ice. Many species couldn't adapt fast enough and went extinct. Some animals and plants migrated north, following the retreating warmth. Others evolved to survive in the increasingly harsh conditions. But with each major shift, Antarctica's biodiversity diminished. Yet, even as the ice sheets grew, pockets of life persisted. In ice-free areas and in the surrounding seas, unique species evolved, adapted to the extreme conditions. These endemic species tell a story of isolation and incredible resilience. Today, Antarctica is changing once again. As global temperatures rise due to human-induced climate change, the continent's ice is melting at an unprecedented rate. In studying prehistoric Antarctica's climate shifts, scientists have gained crucial insights into our current crisis. The past shows us how ecosystems respond to change over long periods. But today's changes are happening much faster. The climate shifts of prehistoric Antarctica occurred over thousands or millions of years, giving life time to adapt. Today's changes are happening over decades, a blink of an eye in geological terms. As Antarctic ice melts, global sea levels rise. Coastal cities around the world are at risk. But it's not just about water, the changing Antarctic ecosystem could have far-reaching effects on global climate patterns. By studying how life responded to past climate shifts in Antarctica, scientists hope to better predict and possibly mitigate the impacts of our current climate crisis. The rocks and ice of Antarctica hold valuable lessons if we're willing to learn them. The story of Antarctica's climate is a stark reminder of our planet's dynamism. It shows us that change is constant, but also that the pace of change matters deeply. As we face our own era of rapid climate shift, the prehistoric past of Antarctica may hold keys to our future. Uncovering the secrets of prehistoric Antarctica is no easy task. It requires bravery, ingenuity, and a hefty dose of scientific curiosity. Let's explore the fascinating world of Antarctic paleontology and the intrepid researchers who brave one of Earth's harshest environments in search of its ancient past. The search for prehistoric life in Antarctica began surprisingly recently. The first fossils were discovered in 1859, but it wasn't until the 1970s that concerted efforts to study Antarctic paleontology truly began. Early expeditions were focused on geological surveys, but occasionally stumbled upon fossils. These chance findings hinted at Antarctica's lush past, but the real breakthroughs were yet to come. Pioneers like James Zumberge and David Elliott laid the groundwork in the mid-20th century. But it was the work of William Hammer in the 1990s that really put Antarctic paleontology on the map, with the discovery of the first Antarctic dinosaur, Cryolophosaurus. Fossil hunting in Antarctica is unlike anywhere else on Earth. The extreme cold, high winds, and isolated locations make every expedition a test of human endurance. Scientists must carry specialized equipment designed to withstand sub-zero temperatures. Simple tasks like taking notes or operating cameras become major challenges when wearing thick gloves in howling winds. But the biggest challenge is access. Most of Antarctica is covered in thick ice, hiding any fossils that might lie beneath. Paleontologists must focus on the mere 2% of the continent that's ice-free, mainly coastal areas and mountain ranges. Once a promising site is found, the race is on. The short Antarctic summer gives scientists a narrow window to work. What might take months elsewhere must be accomplished in weeks or even days. Despite these challenges, the last few decades have seen a boom in Antarctic paleontology. In 2011, scientists discovered fossils of a giant sea lizard, Kaikaifalu, reshaping our understanding of Antarctic marine ecosystems. It's not just animals. In 2015, scientists found two 80-million-year-old tree fossils from a time when Antarctica was still part of Gondwana. These ancient forests are helping us understand how plants adapted to extreme light conditions at the poles. In 2020, the discovery of a 50-million-year-old penguin fossil showcased the evolution of these iconic Antarctic birds. Standing at 1.6 meters tall, it was one of the largest penguins ever to exist. But the work doesn't end in the field. Back in the lab, scientists use cutting-edge techniques to analyze their findings. CT scans reveal the internal structures of fossils. Geochemical analyses of fossil teeth and bones provide clues about ancient diets and environments. By combining data from multiple fossil sites, scientists can reconstruct entire ecosystems and track how they changed over millions of years. This work is crucial for understanding how life responds to major climate shifts, a topic of pressing relevance today. Each fossil found in Antarctica is a piece of a grand puzzle, helping us understand not just the history of this continent, but the story of life on Earth itself. As one Antarctic paleontologist put it, we're not just studying the past. We're uncovering lessons that could be crucial for our future. The scientific exploration of prehistoric Antarctica is an ongoing adventure, full of challenges and breathtaking discoveries. But how has this lost world captured the public imagination? Up next, we'll explore how prehistoric Antarctica has been portrayed in popular culture, from books and films to art and music. Antarctica's isolation and extreme conditions have made it a perfect setting for tales of adventure and horror. H.P. Lovecraft's 1936 novella At the Mountains of Madness imagined ancient alien civilizations hidden beneath the ice, inspiring countless other works. In film, John Carpenter's The Thing played on fears of isolation and the unknown, with its shape-shifting alien emerging from the Antarctic ice. More recently, Happy Feet brought a family-friendly version of Antarctica to audiences worldwide, even if its tap-dancing penguins were more fantasy than prehistory. Documentaries have also brought prehistoric Antarctica to life. Series like BBC's A Walking with Dinosaurs and A Prehistoric Planet have used cutting-edge CGI to recreate the continent's ancient ecosystems, making prehistory accessible to millions. Video games haven't ignored Antarctica either. Games like Ark: Survival Evolved allow players to interact with prehistoric creatures in an environment inspired by Antarctica's past. Impact on public understanding. These pop culture representations have had a significant impact on public understanding of prehistoric Antarctica. While not always scientifically accurate, they've sparked curiosity and driven interest in the continent's ancient past. Every time a new movie or game features prehistoric Antarctica, we see a spike in interest. People start asking questions, wanting to know what's fact and what's fiction. It's a great opportunity for science communication. Museums and educational institutions have capitalized on this interest, creating exhibits and programs that bridge the gap between pop culture representations and scientific understanding. Moreover, as climate change has become a pressing global issue, representations of Antarctica, past and present, have taken on new significance. The continent's prehistoric warmth and current icy state serve as powerful symbols in climate discourse. Beyond mainstream media, Antarctica's prehistoric past has inspired artists across various mediums. Painters and sculptors have imagined the continent's ancient landscapes and creatures, often blending scientific accuracy with artistic license. Musicians, too, have found inspiration in Antarctica's history. From classical compositions to experimental electronic pieces, the continent's transformation from prehistoric warmth to icy waste has been explored through sound. Poets have grappled with the philosophical implications of Antarctica's hidden past. The idea of a lush, life-filled land buried beneath miles of ice has served as a powerful metaphor for hidden potential and lost worlds. While not all pop culture representations of prehistoric Antarctica are scientifically accurate, they play a crucial role. They keep the public engaged with this remote continent and its importance to Earth's history. As scientists, we can build on this interest to share the even more fascinating reality of Antarctica's prehistoric past. As Antarctica's ice now melts due to global warming, we're seeing a reversal of its ancient history. But this modern warming is happening much faster than prehistoric changes, posing significant challenges for life on Earth. Implications for understanding Earth's history and future. Studying prehistoric Antarctica helps us understand how Earth's climate systems work on a global scale. It shows us that what happens at the poles doesn't stay at the poles. Changes in Antarctica can have far-reaching effects on global climate and ocean currents. Looking to the future, prehistoric Antarctica offers both warnings and hope. It warns us of the dramatic changes possible in Earth's climate system. But it also shows us the incredible resilience and adaptability of life. By understanding how life responded to past climate shifts in Antarctica, scientists hope to better predict and possibly mitigate the impacts of our current climate crisis. The rocks and ice of Antarctica hold valuable lessons if we're willing to learn them. As we conclude our journey through prehistoric Antarctica, we're left with a profound appreciation for the complexity and resilience of our planet. This frozen continent, seemingly so static, tells a story of constant change, adaptation, and survival. From the lush forests of the Cretaceous to the icy expanses of today, Antarctica's journey through time mirrors the greater story of Earth itself. It reminds us that our planet has a history far grander and more varied than we often imagine, and that the world we know is just one chapter in an ongoing saga. As we face our own era of rapid environmental change, the tale of prehistoric Antarctica offers both a warning and a glimmer of hope. It warns us of the profound changes possible in Earth's systems, but also reminds us of life's remarkable ability to endure and adapt. Hit that subscribe button now and press on the video now popping on your screen. I am sure you will love it. Don't forget to leave a like on this video and see you there.